This is Geometry, Unit 5, Lesson 2, Proofs of Parallel Lines. It is very, very important to know your angles and what they do when you have parallel lines cut by a transversal. It is important because these can be used as reasons in proofs. You need to memorize these. You should be able to recognize them and be able to apply them. So let's run through them quickly. If we know lines are parallel, then the corresponding angles are congruent. So if L1 and L2 are parallel, what angle would be a corresponding angle with angle 1? Well, angle 1 is here. Remember, corresponding means in the same place. Angle 1 would be congruent to angle 5. So if you know the lines are parallel, you can automatically say that angle 1 is congruent to angle 5. And the converse is also true. If you have a pair of corresponding angles are congruent, then the lines are parallel. Well, if I had angle 2, what angle would have to be congruent to angle 2 to make the lines parallel? Well, if I have angle 2 right here and it's a corresponding angle, it would have to be congruent to angle 6. So if angle 2 is congruent to angle 6, then I can say L1 is parallel to L2 because the corresponding angles are congruent. So it works both ways. The next kind is alternate interior angles. If lines are parallel, alternate interior angles are congruent. Remember, alternate interior means between the parallel lines, and the alternate means on opposite sides of the transversal. So if I have angle 3, and these lines are parallel, what would be its alternate interior angle? It would be angle 5, because it's on opposite sides of the transversal. Now you could also do 4 and 6 would be fine. So, if lines are parallel, alternate interior angles are congruent. And also, conversely, if you have alternate interior angles congruent, then you can say the lines are parallel. So, as I just said, if angle 4 is congruent to angle 6, that forces these two lines to be parallel. So if corresponding angles are congruent, lines are parallel, and if alternate interior angles are congruent, lines are parallel. Now the third kind are same side interior angles. They're not congruent necessarily, but they are, if lines are parallel, same side interior angles are supplementary. It means that adds up to 180. So if L1 is parallel to L2, and I have angle 4, what one would be a same side interior angle for that angle? It would be angle 5 down here. Angle 4 and angle 5 should add up to 180 degrees because that would be supplementary. And conversely, if the same side interior angles are supplementary, that forces the lines to be parallel. So if I had angle 3, what would be the same side interior angle with it? It would be angle 6. So angle 3, if angle 3 and angle 6 add up to 180, that means that these two lines must be parallel because they're same side interior angles. You need to know these angles and their converse. Now let's try an actual proof that uses these theorems. We have quadrilateral ABCD with AB parallel to CD. These two lines are parallel. And we're also given that angle D is congruent to angle B. And we want to prove that ABCD is a parallelogram. Now remember in the last unit we talked about parallelograms. Both pairs of opposite sides have to be parallel. That's why it's called a parallelogram. Both pairs of opposite sides must be parallel in order to prove it's a parallelogram. Now, do we have both pairs of opposite sides? No, we only have the one pair. So we already know that AB is parallel to CD. So that gives us a good start. We need to prove that AD is parallel to BC. So that's what we're going to do. All right, so let's put down what we know so far. We know we have a quadrilateral ABCD. And we know that AB is parallel to CD. That's given. All right, now our goal is to get these two sides right here parallel. We don't know what they are, but we want to prove they are. Now, from the theorems we were just talking about a minute ago, we have to get lines cut by a transversal with angles congruent or supplementary to prove that you have parallel lines. Okay. We do know that AB and CD are parallel. So that means that AD and BC over here must be their transversals that touch the two lines in one place. So if we know that, if these two lines are parallel right here, and this is a transversal, do we know anything about the angles? Well, what about angle A and angle D right here? What kind of angles are they? Aren't they same side interior angles? If this is parallel lines, this is your transversal. These are on the same side of the transversal between the parallel lines. So that means they are supplementary. So angle A is supplementary to angle D, because if lines are parallel, same side interior angles are supplementary. Okay, so these two right angles right here are supplementary because we know that these two lines are parallel. So these are same side interior angles. Now, if they are supplementary, what do we know about them? Well, we know supplementary means they add up to 180 degrees. So the measure of angle A plus the measure of angle D is equal to 180 degrees. Supplementary angles add up to 180 degrees. That's the definition. Okay, so we know A plus D is 180. Now, we had another statement about angle D. We knew that angle D is congruent to angle B. That was given. Well, if A plus D is 180, what else could we say? Well, if D is equal to B, couldn't we say that the measure of angle A plus the measure of angle B is equal to 180? Yeah, that's by substitution. We just took B and plugged it in for A. We took statement 3 and we plugged in statement 4. So here for D, instead of writing D, we wrote B in there and we rewrote it. So that's pretty much what we did. Now, so we just said that A and B are now supplementary because they add up to 180 degrees. So angle A is supplementary to angle B. These two angles right here are now supplementary, okay, because supplementary angles add up to 180 degrees. Okay, so we just proved that angle A and angle B are now supplementary. Well, if we want to prove these two lines parallel, wouldn't that make AB my transversal? Well, if AB is my transversal, where are these two each other? They are same side interior angles. Well, didn't we just prove they're supplementary? Yeah, we did. So that means that AD is now parallel to BC, because if same side interior angles are supplementary, then lines are parallel. Okay, so we just proved that this angle and this angle are supplementary to each other, so that makes that these two lines right here are parallel because these are same side interior angles that are supplementary. So now, is this a parallelogram? Yes. ABCD is a parallelogram because both pairs of opposite sides are parallel. We proved AD is parallel to BC, and we were given that AB is parallel to CD. So a parallelogram has both pairs of opposite sides parallel. So we used both same side interior angles being supplementary from parallel lines, and we used its converse. If the same side interior angles are supplementary, then the lines are parallel. We use both of them. So that is using them for same side interior angles. Let's try one more. In this picture, we are given that AB is parallel to CDE. So this line is parallel to this line. So we should be looking for transversals when we do that. We have BDF. All right, notice BDF touches both lines, so that's probably going to be my transversal. And we have CD bisects angle ADF. All right, so here's CD and here's ADF. So think about what a bisector does. We'll get to that in just a second. All right, now we are trying to prove that angle DAB, which is this angle right here, is congruent to angle DBA, which is this angle right here. We're trying to prove those two angles are congruent. So let's see what we know about angles from parallel lines. We are given AB is parallel to CDE, and we have BDF. Now, since that touches both of the parallel lines, that means that BDF is a transversal. So, do we have, this is given, if these lines are parallel right here, and this is my transversal, let me color them in a different color. Here's my parallel lines, and there's my transversal. Okay? Do I have a relationship between those parallel lines and any angles? Well, what about angle DAB right here? Do I see an angle that would be congruent to angle DAB? Well, what about this angle right here? What kind of angles are those? Aren't those alternate interior angles? So I can say angle DAB is congruent to angle CDA. Because if lines are parallel, alternate interior angles are congruent. So those two angles are congruent. Okay, so I proved those two. This one is now congruent to this one. Now, do we know anything else about this angle? Well, we were given that CD bisects angle ADF. CD bisects angle ADF. Now, what does a bisector do? That's given. A bisector divides an angle into two congruent angles. So what two angles are congruent? Well, here's CD, here's ADF. So that means angle CDA is congruent to angle CDF. So this angle is congruent to that angle. Those two angles are now congruent. A bisector divides an angle into two congruent angles. Two congruent angles. All right, now, we now have a relationship between these two angles right here. So CDA is congruent to CDF. All right, and then look at my statements here. DAB is congruent to CDA and CDA is congruent to CDF. So that means angle DAB is congruent to angle CDF using the transitive property. Using transitive. So I've got this angle is now congruent to this angle. Now, does this angle right here have any relationship to angle DBA down here? Yeah, if these lines are parallel, what kind of angles are these right here? This one and this one. Where are they? Well, they are corresponding angles. So angle CDF is congruent to angle DBA. If lines are parallel, corresponding angles are congruent. So we now have CDA is congruent to CDF, DAB is congruent to CDF, and CDF is congruent to DBA. So look what we have here between 5 and 6. DAB is congruent to DBA. And that's also by transitive. Okay, this transitive back here was on numbers 2 and 4. And this transitive right here is on numbers 5 and 6. So we approved it. Is this the only way to prove this? No, there's other ways we could prove it, but this is just one way. So we used parallel lines, alternate interior angles to get these two angles congruent. And then we used corresponding angles to get these two angles congruent. So you can use any kinds of angles that you have as long as your lines are parallel. All right, so that's the end of the notes for today. We'll be doing the homework in class tomorrow. I would learn your angles and how to use them.